All right, hello everybody. This is going to be the tutorial video for section 7.1 on ratios and proportions, first section of chapter 7. Real important that you watch this video because everything that we talk about this chapter that has to deal with similar triangles or geometric mean, anything we do is going to be based on the vocabulary as well as some of the algebra skills from this section. So it's real important that you watch this video so that you are up to date with everything we need for the rest of the chapter. Please, please, please give it a watch. Okay, ratios and proportions is something you talked about in Algebra 1, so a lot of this will be a recap, but there is some new vocabulary that we're going to introduce specifically with the proportions that you probably have not heard of before. Okay. So first off, what's a ratio? This is just a comparison of two quantities, and you've heard of plenty of examples in your life before I'll give you. So a ratio, there's the daily lag, is a comparison of two quantities. And you can express it in three ways. You can write it as a fraction, a to b. You can write it with a colon, which we would read a to b, not t, b, a to b. Or you can actually write that with the word to, a to b. These all mean the same thing, but you always want to make sure that you reduce, simplify the ratio. And you'll see I have some cookies and ice cream at the top. It's making me hungry. Hopefully it's not making you hungry. We want to know what is the ratio of ice cream cones to cookies. Okay, let me do two different colors. Cookies will be green. It's important that you look at the order that they list them in. Whatever comes to the left of the word to, you need to list first in the ratio. Whatever comes to the right of the word to, you need to list second. So I count one ice cream cone, and I count 1, 2, 3 cookies. So this would be a 1 to 3 ratio. If I said cookies to ice cream, then it would be 3 to 1. So it's important that you look at the order they list it. Other examples, pause me for 5, 6 seconds. See if you can think of any examples of real life ratios you've heard of before. I'm going to write some out. Most popular one in school would be like a teacher to student ratio. There's typically one teacher for every 20 to 30 students. Okay. So e.g. 1 to maybe, our class is roughly about 24, I think. 1 to 24. Cooking, if you've done cooking or baking, being able to convert things between cups, teaspoons, tablespoons. And I think the most popular example I could think of would be a map scale. If you've ever looked at a map, sometimes you'll see something in the bottom left corner that says like 1 centimeter for every 10 miles. You clearly can't fit 10 miles on an actual piece of paper, on an actual map. So they have to scale it down in such a way so that it fits on that piece of paper. So that would be an example. If you can fit 10 miles on a map, you're a mathematician. Okay, first example I see here. A small plant has a height of 8 inches. A larger plant has a height of 4 feet. We want to find the ratio of the height of the small plant to the height of the large plant. So I'm going to label small plant comes first, large one comes second, based on the order that they listed it. So I want small to large. Okay. Now, whenever you're going to compare two quantities that are both heights or both lengths that are in different units, you want to make sure that you convert those quantities to the same units, because we want the units to cancel out at the end if we're measuring in the same unit of measurement like height or length. So in my problem, I need to convert the feet to inches or the inches to feet. I'm going to choose to convert the larger plant. The large plant was 4 feet. Remember that there's 12 inches. 12, come on. Oh no, it's not writing. Hang on. Oh no, Microsoft Word needs to reopen, sorry. It's restarting, it'll be up in a second. There we go. Okay, so 12 inches. Let me get my pen working again. You need to know that there's 12 inches in 1 foot. So I'm just going to do 4 feet. I'm going to do a little unit conversion here. There's the lag again. 4 feet. 1 foot is 12 inches. I'm setting this up. If you've taken physical science or chemistry, you've probably seen dimensional analysis like this. I'm really just multiplying 4 times 12. So this would be 48 inches. They said small to large. So now that I have everything in inches, the small one was 8 inches. The large one was 48 inches. The nice thing now is the inches cancel out. So I'm just reducing 8 over 48, which is a 1:6 ratio. You always want to reduce. I'm just going to make a comment here. Reduce. Okay, extended ratios. This is when we are comparing 3 or more values. And a very popular example of these would be with a triangle, because you have 3 side lengths. It says the lengths of the sides of a triangle are in the extended ratio 3 to 5 to 6. So I'm going to draw a triangle. The perimeter of that triangle is 98 inches. What is the length of the longest side? That's our end goal. Okay, one thing I'm going to clarify here. By them telling you the ratio is 3 to 5 to 6, it doesn't mean that the side lengths are 3, 5, and 6. First of all, that doesn't make sense because the perimeter is 98 when you add up the 3 sides. 6 plus 5 plus 3 is 14, not 98. So by them telling you the extended ratio is 3 to 5 to 6, it's a small tweak to what I have written already. It means that one side is a multiple of 3, one side is a multiple of 5, and one side is a multiple of 6. So I'm just tagging an X onto each of them, because if I divided X out from each of these, I would still reduce to 3 to 5 to 6. So that's the one thing you got to make sure you tag next to the 3 numbers they give you. Put an X. Now I can use the perimeter. Those 3 sides need to add up to 98 inches. And then I do a little algebra to get X. 14X equals 98. Divide, divide. We get, what did I get from that? 7. Plug it in. Longest side would be the one with the 6. 6 times 7 would be 42. So my longest side here would be 42 inches. Now, good way to check your work. Find the other ones too. 3 times 7 would be 21. And 5 times 7 would be 35. If you take the ratio 21 to 35 to 42, it should reduce to the ratio they gave you. And it does, because if you divide all of these by 7, that's the biggest number that fits into all 3. 21 divided by 7 is 3. 35 divided by 7 is 5. And 42 divided by 7 is 6. Perfect match. So that's a good way to check your work. See if it comes out to the extended ratio that they gave you. All right, so that's ratios. A proportion, you spend a good amount of time, maybe in the beginning of Algebra 1, setting these up. A proportion is just a statement or an equation. Think of it that way. It's an equation that says 2 ratios are equal. So think of it like this. One ratio is A over B. Another ratio is C over D. The equal sign is what makes it a proportion. Individually, they're just ratios. I mentioned at the beginning of the video that some new vocab would be coming into play for the geometry piece of this. This would be one of those moments. We have special names for the top left corner and the bottom right corner of the proportion. A and D are what we call the extremes. I'll put those in green. B and C in the bottom left corner and the top right corner are what we call the means. Okay. So top left, bottom right are extremes, bottom left and top right are the means. That is 2 pieces of vocab that you will hear me referring to throughout the chapter. One nice thing we can do with proportions is cross multiply them. I'm sure that's a throwback that you remember from last year. Cross multiply. The fancy phrase for this in geometry is the cross product property. Okay. And what it says is that if you take the 2 extremes, A and D, and you multiply them together, you should get the same result as taking B times C. So if I multiply the two extremes and I multiply the two means, I should get the same product. So in this case, that would mean A times D is equal to B times C. Set those products equal. Let's do a couple examples with that. In number or letter A, I have x over 5 equals 12 over 7. I want to get x. So I'm going to multiply my two means or my two extremes together. X times 7 would be 7x. And then I'm going to multiply my two means together, 5 and 12, equals 5 times 12. And then I solve. 7x equals 60. Divide, divide. 60/7 is about as good as it gets. That's not a whole number. Second one, I'm going to highlight my extremes in yellow. Those need to multiply together. And I'm going to highlight my means in blue. Those need to go together. Now, the only thing you got to be careful with here is you're adding y plus 3. When that 4 multiplies by that top left corner, it helps if you put this in parentheses to remind yourself that that 4 needs to distribute to the y and it needs to distribute to the 3. If you don't write it, you're going to see it like this, and you're only going to multiply 4 by y. That's not what we're going for. The right-hand side would be 8 times y. 2 hops. 4y plus 12 equals 8y. Move my y's to one side. From here, it's just some algebra. 12 equals 4y. Divide, divide. And I get y equals 3. Okay. So really the new piece, or not new, but the reminder is more on the cross multiplying. The rest of it is good old equations that we've been using the whole year so far. Okay. Did I lose a piece? There was supposed to be something else here. Okay, pause for 1 second. I need to open up the actual handout that I had because I have an updated version. No, things disappeared. Okay, we'll do this instead. This one should be correct. There it is. I'm just going to open it up in a new platform. Sorry for the delay. There we go. Okay. There we go. Okay. If two proportions have the same cross product, we say the proportions are equivalent, meaning that they cross multiply to the same result. And this is what's going to allow us to look at how we can move proportions around. In the first one here, I have if x over y equals 5 over 6. First thing it wants me to do is just cross multiply. 6 times x would need to equal 5 times y. This is what we call the cross product. Cross product. Now, the next three, what I'm going to do is mess with the proportion in a certain way so that I get the same cross product. So my goal in the next three is going to be to get 6x equals 5y. So if I want to fill in the blank, that means that I need to put a 5 in the bottom right so that 5 gets multiplied by y. And I need to multiply x by 6 to get 6x. And if you look at what I did, I basically just took the original proportion and I flipped it upside down. So I flipped the two ratios upside down, USD. In C, now I would need to put, if I need x, I need 6x, I would put 6 in the bottom right, and I would put y in the top right so that I get 6x equals 5y. Notice what I did in this one. It's a little more subtle. In the original proportion, my means were y and 5. Notice that they flipped positions now. So all I did is I switched the means. That is a legal move, and it creates an equivalent proportion. This one is 6x equals 5y. This one is 6x equals 5y. The original one was 6x equals 5y. So far, they're all equivalent. This one, I would need to put an x in the bottom right to get 6x. I would need to put a 5 in the top right to get 5y. This one, do a different color. This time, I switched the extremes. So if you'll notice, 6 and x reversed roles. Reverse, reverse. I switched the extremes. Another legal move. And cross multiply it to check, you still get 6x equals 5y, like we had in part A. So these are all equivalent proportions. Here's my mouse. Because they cross multiply to the exact same result. Okay. In B, we took the reciprocal of each ratio. In C, we switched the means. And in D, we switched the extremes. These are the three most popular equivalent proportions that you can create. So these are ones that you should be familiar with. Let's look at an application. Let's say that you want to build a pool in your backyard once the spring rolls around, because it's definitely going to be too cold this weekend with the negative temperatures, right? Nobody wants to go swimming. You've already drawn a scale model to help persuade your parents. Here's your scale. Remember how I talked about maps at the beginning? 2 inches represents 7 feet. So on your picture, your model of the pool, the 7 feet that the actual pool is going to take up is only going to be 2 inches on your model that you're drawing. So that's important. Here's your scale model. I'm going to draw it. We're going to assume the pool is a rectangle. Width and length are 5 inches and 7 inches. So 7 inches, 5 inches. The actual pool, we don't know. We want to find the actual dimensions of the pool. So I'm going to draw a little bit of a bigger pool. And I'm going to use the dimensions x and y. Okay. And these are going to be in feet, because I notice in my scale model, I'm using inches, but on the right-hand side of the ratio, they're talking about feet. So this will be in feet, and this will be in feet. First thing I'm going to do, I'm going to try to find either x or y using 2 inches to 7 feet. So this is how I set it up. If 2 inches represents 7 feet, that's my scale model. I'm going to start with the 5 inches. I don't know how much 5 inches would be. So I'm going to set 5 inches over x feet. Notice how I kept things consistent from the left to the right. Inches was on the top on the left-hand side. Inches was on the top on the right-hand side. Feet was on the bottom on the left-hand side. Feet is on the bottom on the right-hand side. So you're using your scale model, that 2 inches to 7 feet, to help yourself figure out what 5 inches would be in the actual pool. So I'm going to cross multiply. 2x equals 35 means that x would be 17.5 feet. So this guy's 17.5. And then I'm going to do the same thing for the 7 inches. So number 2, again, I use my scale that I created, 2 inches to 7 feet. This time I want to know what would 7 inches be. That's going to correspond to y feet. So I cross multiply again. 2y equals 7 times 7 is 49. Dividing by 2, this would give me 24.5 feet. So your pool would be 24.5 feet by 17.5 feet. And once the weather gets nicer, you can go swimming. If you need to pause and take a look at that again, go for it. Okay, extended proportions. This is when 3 or more ratios are equal. And a good way to be able to work with these is to use your cross product property, your cross multiplication. If you look at any 2 ratios that are right next to each other, you should get the same cross product here. 6 times 16, check this, this would be 96. 24 times 4 would also be 96. And then if I look at 4/16 and a fourth, I'll do this in blue. If it loads, there we go. Let's look at these two. 4 times 4 would be 16, and 16 times 1 would be 16. So you should be getting the same result when you cross multiply them. And that's a good strategy to fill in the blanks if you're missing some. So for example, in letter A, I have 2 question marks I have to find. I'm going to start with the 2 ratios on the left and in the middle. I see 12 times 6 would be 72. So I need 8 times this question mark right here to also equal 72. And if you're not sure what that is, divide it. 72 divided by 8 would be 9. So in blue, that question mark is 9. The other one, now that I know this is 9, I can do these two. 12 times 9 would be 108. That means I need these two. 6 times this question mark needs to be 108. I'm going to divide 108 by 6. I get 18. So the other question mark comes out to 18. In B, I'm going to start with 14 times 12. 14 times 12, that needs to be 168. So that means these 2 question marks need to also be 168, but I don't know what either question mark is. And I can't use one question mark to help me get the other one yet. They're both missing. So that means I need to work my way over to the right-hand side to get more info. I see 12 times 35, so I'm going to work with that. 12 times 35 would be 420, which means 20 times this top question mark needs to be 420. So I can do 420 divided by 20. 21. So now I know that one's 21 in blue. Let's do the bottom one in red. That means 21 times that bottom question mark needs to be that 168 we mentioned from the beginning. So I'm going to do 168 divided by 21. 8. So this guy's 8. Okay. So I'm using cross multiplication to help me figure out the missing values in the proportion. Last thing in this section I'll give you a couple reminders on is FOIL and factoring. These are techniques that we're going to need the rest of the chapter, and they will pop up throughout the rest of the year. They look like normal proportions. It's just that the algebra gets a little bit messier. First thing I'm going to do, everywhere I see addition and subtraction, I'm going to put parentheses around the top, since I know distributing is going to have to happen. I want to solve for x, so I'm going to take the top left corner, multiply it by the bottom right corner. Notice the parentheses. Equals, and then I'm going to take the bottom left corner and multiply it by the top right corner. Those means 6x times x minus 1. The right-hand side is a little bit easier, so I'll start with that. 6x times x. Remember that x times x is not 2x, it's x squared. You have to add those exponents. So this would be 6x squared. 6x times -1 would be -6x. So that takes care of the right-hand side. The left-hand side uses FOIL or double distribute if you liked using that last year. I'm going to multiply the first terms together. 2x times 3x would be 6x squared. I'm going to multiply the outer terms together. 2x times positive 4 would be 8x. That's the O. I stands for inner. I'm going to multiply the inner terms together. Negative 3, since I see a sign to the left of it. Negative 3 times 3x would be minus 9x. Check. And then L stands for last. Negative 3 times positive 4 would be negative 12. So I'm multiplying all the pieces together, and then I'm adding up the results. Now I combine my like terms together. So I see an 8x and a negative 9x. 6x squared minus 1x minus 12. On the right-hand side, I see 6x squared minus 6x. We've talked a little bit this year about how whenever there's x squareds, you usually have to factor. But in this one, it's actually a little bit easier. Notice how you have a 6x squared on the right and you have a 6x squared on the left. If I subtract that from both sides, that quadratic term actually disappears and it just turns into a normal algebra problem now. These carry down and this negative 6 carries down. Make sure you carry the negative down. So I solve it like normal. Plus 1x. Negative 12 equals negative 5x. I'm going to divide both sides by negative 5. You have a negative divided by a negative, so your answer is going to be positive 12/5. Okay. If you want a little more review of FOIL, go back to our notes that we had, I believe, from the second day of school. We did a nice FOIL and factoring review there, but I'll do one more just so you can see a second one, and this one has some factoring involved. I'm going to put parentheses around anything that uses addition or subtraction. Parenthesis, 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 parenthesis. And then I'm going to cross multiply. These two extremes get multiplied together. And then I set it equal to the product of those two means. 8 times 10 would be 80. Notice the left-hand side needs FOIL again. So I do first times first. X times x, remember my reminder, is x squared. X times 2 would be 2x. 4 times x would be 4x. And then 4 times 2 would be 8. Unfortunately, we don't get the x squared to cancel on this one. We get x squared plus, not 4x, 6x, plus 8 equals 80. This looks like a factoring problem because of that quadratic. So I need to get 0 on one side. I'm going to subtract 80 over to the left. X squared plus 6x minus 72 equals the magic number 0. And here's the fun step. We got to find two numbers that multiply to negative 72. And I need to find the same two numbers adding up to positive 6 in the middle. Pause me. I want you to try this. Pause it, see if you can find the numbers, and then replay the video when you think you've got them. So you should have gotten positive 12 and negative 6. Okay. Needs to be a positive and a negative so that they multiply to a negative. So now to factor it, the only way to get x squared is if I have x's in front, and now my magic numbers go next to the x's. Positive 12, negative 6. Set them equal to 0. If x plus 12 equals 0, then x equals negative 12. If the other factor, x minus 6 equals 0, add the 6 to the other side, x would equal positive 6. So 2 answers for that one. And we're not plugging in for angles or side lengths, so don't worry that you have a negative answer. This is kind of just an algebra problem right now for review. The geometry is coming soon to a math class near you. All right, that's what I got for 7.1. Please make sure that you do the Math Excel. We are going to move on next week to 7.2 and use these skills. So please do the homework. See ya.